Okay, this is your translations foldable, and make sure that you take extra good notes. So the front cover, we have a nice picture here. So a translation maps all the points of a pre-image the same distance and the same direction. So this is basically going to be a slide. Okay, so same distance and the same direction. So a lot of people call this a slide, because you just slide it across the page in whatever direction they say. So the shape of it stays exactly the same. So if we look at our picture, we have our, over here, this is our pre-image, because it's our first one, and this is going to be our image, because we have the primes on this one. Remember, all the primes tell you it's going to be the second one. Okay, so let's see what this says. So it says a translation XY. If you move it x minus 4 and y minus 4, maps the pre-image ABC to its image A prime, B prime, C prime, which happens to be 4 units to the left along the x-axis and 6 units down along the y-axis. So if you notice this right here, so this part right here, this x minus 4, that is your x-axis, right? So that means I'm moving it minus 4 on the x-axis. So that means 4 to the left. And that's how they're getting 4 units to the left. So those two match up. So match those with the color. So this is along the x-axis. So this x minus 4 means 4 to the left on the x-axis. Then we have the y minus 6. I got a different color now. And that is y. So that is on the y-axis, up and down. So since it's minus 6, that means it's going down 6 spaces. Now remember, if either of these were positive, they'd be up and to the right. So it tells you that this is 6 down along the y-axis. So that's what this little notation means. It just takes all your x, scoochy him 4 to the left, and the y, scoochy 6 down. It also can be described in words, like we just did, 4 units to the left, blah, blah, blah. Or it could be written in either of any of these 3 ways. So the first way it could be written is just like this. Notice these are pointy brackets, like little vectors. You see the little pointy. So if you see the pointy brackets, that does not mean it's a point. It means that it is moving at 4 on the x-axis and negative 6 on the y-axis. They can also write it like this, kind of similar to how we had the last thing with like the R, and then we put like x-axis down here. So it's the same idea right here. That's a T, and the T stands for translation, and you see how this is lower down here? And that means I'm going 4 on the x-axis, negative 4 on the x-axis, and negative 6 on the y-axis. And it looks similar. So it's basically like moving that triangle, and the new result is A prime, B prime, C prime. Or you can write it like they did up in the top up here, like this. So that means I'm taking any point x, y, and I'm moving the x coordinate negative 4 spaces, and I'm moving the y coordinate negative 6 spaces. So that's what that means. So just like the last one, it's going to have some properties. So if I look at this picture, I could see those properties. I could see these parallel lines. See this line, A to A prime, and B to B prime, and C to C prime. All of these are going to be parallel. So all 3 of these are parallel to each other. So that's what this is saying right here. The next one, it says that they are congruent in length, which means if I were to measure from here to here, the length of this, it would be the same as the length from here to here. It would be the same as the length from here to here, which makes sense because you're moving every single point exactly the same way. Like basically you're moving them up, or I'm sorry, to the left 4 and down 6, and I'm moving all of these points. So they're going to be all the same distance. So that's what they're talking about here. A, B, and C, and A prime, B prime, C prime, these 2 triangles have the same orientation, which means notice how they're not spun. They literally have been slid up and over, or to the left and down, or something like that. They don't spin or flip. So when it has the same orientation, this is no spinning, no spin, and no flips, right? So it's going to look exactly the same, just slid somewhere else. And this is a rigid motion. It's a rigid motion because the length of the sides and the angle measures are preserved. So it's a rigid motion. It preserves both size and shape stay the same. Size and shape are preserved, which means basically frozen just like they are. Okay, make sure you have some good notes on the front. If you think of anything else, you might be able to squeeze it at the bottom if you have some things to remember. So let's go ahead and open this one up. I think this one's pretty much easier than the reflections, but maybe you can be the judge of that. Okay, so let's check this out. I'm going to make this a little bit smaller so it fits on the screen for you. Okay, so it says, what is the graph of the translation 3, -5? So what does 3, -5 tell us to do? 3 means positive 3 on the x-axis, right? And the 5 is -5 on the y-axis. Okay, so what's positive on the x-axis? Positive on the x-axis is going this way, right? So it's going to be to the right. Now on the y-axis, what is -5 on the y-axis? So this is the y-axis. So if I go -5, negative is down, right? So this is going to be going down. So I'm going to be moving this figure to the right and down. To the right 3, down 5. Always stop and figure this out. So the x1 is always right left because that's where your x-axis goes. And the second number is always up down because that's your y-axis. This is an xy. Okay, so I have a triangle, EFG. So E is at the point -5, 4. So I got to go backwards 5 and up 4. 1, 2, 3, 4. So that's there. That is my E. I'm going to label him. Okay. Then I have my F, which is at -1, 5. So that's back 5 and up, back 1 and up 5. So this is my F. And then I have my G, which is at -2, 1. So back 2, down 1. So that's right there. That's my G. So here's my triangle that we're talking about. He's green. Okay, now I want to translate. So I'm sliding him. I am sliding him 3 places to the right. So take each one of these points, 1, 2, 3, all 3 points, and move them 3 spaces to the right and 4 down. So I'll make bubbles for this first one. So for this F is 1, 2, 3 spaces to the right, and 1, 2, 3, 4, 5 down. So my F prime is right here. I'm going to show you how to do it this way. Then I'm going to show you another way too. I got to do that to all the points. So I've got to take this E, 3 to the right, 1, 2, 3, and 5 down. 1, 2, 3, 4, 5. It's going to be landing right on top of that, right? So that's going to be my E prime. My last point is this one, right? So 3 to the right, 1, 2, 3, and 5 down. 1, 2, 3, 4, 5. And that's going to be my new G prime. So my shape ends up here. So you can see my black one and my green one. They are congruent. The orientation is the same. They just slid, right? Okay, the second way you can do this, you can do this right from the points. So let's take these points. This is excellent to check your work too. I would do it both ways. So if I have E is negative, okay, my F, I'm writing this because I'm going to do some math on it. And then G is -2, and plus these are your notes, so you should make them awesome. Okay, so I'm going to go ahead and do this stuff to them, okay? So I'm going to +3 onto the X coordinate. So I'm going to +3 on this one, +3 on this one, +3 on this one. Okay, and then I have to -5 on the Y coordinate. -5, -5, -5. Okay, and then I just do some math. Now, you need to use your calculator because this is a -5 plus a 3. So -5 plus a 3 is -2. I have a 4 plus a -5. That is a -1. So that means my E prime is there. F, -1 plus 3. It's going to be a 2. Then I have 5 plus -5. That's 0. And then my G prime, I've got -2 plus 3. That's a 1. And I've got -1 plus a -5, and that is a -6. So this is where all my points should be without even drawing a picture. Let's see if I'm good. So E prime says -2, -1. So go back 2, 1, 2, and down 1. Yep, that's exactly where he is. This guy checks out. Let's try F. 2, 0. So that means to the right 2, boom, boom, and up nothing. Perfect. That's exactly where he is. 1, -6. That's to the right 1 and down 6. 1, 2, 3, 4, 5, 6. Bam. You see how I did it both ways and they both matched. Always do both ways. Check them. So you're doing this up here mathematically, algebraically, and you're doing it over here graphically. And they should be the same. Now, obviously, if I did this work and something didn't match, then I messed up either here or here, and that's an excellent check for yourself. Okay, what translation maps P to P prime? So first of all, which one's the starting one? P is the starting one. That's this guy. So you're always starting from there. And this one here is the image one. So this is the second one, right? So think of the rule that gets you from here, this blue point, to this red point. And now remember, you want to put it what you do on the x-axis and what you do on the y-axis. So since this is the x-axis, I want to try to travel over and see how far I have to go. So on the x-axis, I have to go 1, 2, 3, 4, 5 spaces. So, and that was in the +5 direction, right? So I'm going to do x plus 5 to scoochie him over, right? And now I want to do how far up and down. So I'm doing y second. So up 1, 2. So that is up 2. And that is positive. So that is a y plus 2. So here is my rule. So this is a rule. So remember, we can write it different ways. We can write it like the capital T. And then on the travel on the x-axis 5 and the y-axis 2. You can write it like that. And sometimes they put little brackets around down here too. You might see it like that. Sometimes, remember, they could just write it with these vector-looking brackets, 5, 2. If you see that, that says the same thing. Or I could write it in coordinate form where I say every point x, y basically travels, moves to, gets changed to an x plus a 5 and a y plus a 2. And I could even put it in words that says, just like we had words on the front of the page, that says something like, literally like move 5 to the right and 2 up. So this is 1, 2, 3, 4 different ways to write the same rule. So the rule can be written in 4 different ways, and you'll see them in all ways. So make sure you know how to do all of them. The next question says, what is the distance from P to P prime? So what do we do for distance? How do we find distance? We need the distance formula. Yep, it never goes away. Distance formula. The distance formula, okay, so that means I need the ordered pairs for these 2 points. So this point is at 1, 2, 1, 2, 3. So 2, 3. I need this point, which is 1, 2, 3 backwards and 1 up. So that's -3, 1. So remember, distance formula says that I'm going to do distance equals big giant square root I've got to do my x sub 2 minus my x sub 1, quantity squared, plus my y sub 2 minus y sub 1, quantity squared. All right, so I got to plug these numbers in. So it doesn't matter which you pick. I'm going to call him my x1, y1. And I'm going to call him my x2, y2, just for the heck of it. It doesn't matter which one, because the distance between these 2 points from here to here is the same if I go this way or that way, right? Okay, so let's start plugging these in. So I've got d is equal to square root x sub 2. You should pause the video, do this yourself, see if you remember it. Minus a negative 3 squared plus y2 is 3 minus a 1 squared. Okay, so I've got d is equal to, what do we have in these parentheses? 2 minus negative 3 is 5 squared plus 3 minus 1 is 2 squared. So I've got square root of 25 plus 2. Remember, if you have some negatives, oops, that's a 4, sorry. Let me erase that. That's a 4. 2 times 2 is 4. So this is the square root of 29. And remember, you can put that in a calculator. Square root of 29. I'll go ahead and do that. Of 29. And I get approximately 5.39 units. 5.39 units. And let's look at the picture, see if that makes sense. Okay, so does this look like it's about 5 long? Like, check out these boxes. There's 1 box, 2 box, 3, 4, 5. Yeah, and it's on an angle, so 5.39 seems totally legit. Now, if I said 29, that would make no sense that there's 29 blocks in between these 2 P's. That's crazy, right? So that would tell you forgot to take the square root, okay? Okay, on the next slide, it says a composition of rigid motions is when you perform, so a composition is when you perform more than one transformation. So we did actually, some people got to that one on the little tickets we were doing the other day. So make sure you know it's more than one. So you just do one, then the other. So it says segment MN is translated 1 unit to the right and 3 units down, and then it's reflected across the line y, x equals y. This can also be written like this. So you know a translation can be written like that, 1, negative 3. And we know a reflection can be written like that. Now, do you see this right here in between? That's the little symbol that says to do this and then do that. So that's what the symbol means. That means it's a composition of function that says do one, do the first one, and then do this, then the second one, right? There's 2 of them there. Do the first one, and then the second one. Sorry, that says 1. Oh, good Lord, have mercy. Okay, so let's take a look at this picture. So this is segment MN. So I'm just going to call it MN like this, since they didn't tell us how to name it. I'm just going to do it. I need to go 1 unit right and 3 down. So let's take this first point M. I'm going to go 1 right in my head and 3 down. 1, 2, 3. So my new M, my M prime, is going to be right here. And I got to do the same thing to my other point N, right? So I got to go 1 to the right and 3 down. 1, 2, 3. And so that means that my point N prime is right here. Okay, so my line has moved to there so far. That right here is my first transformation. 1 to the right and 3 down. Okay, now I need to take this and reflect it over the line y equals x. So y equals x is when x's and y's are exactly the same. So that is basically this perfect diagonal line. It's hard for me to connect corner of a box. I try to connect corner of a box to corner of a box, corner of a box. Okay, so here is my line of x equals y. And actually, remember, like, this is 2, 2, because x is equal to y. And this is 3, 3, because x is equal to y. This is 4, 4. This is negative 2, negative 2. This is negative 3. So that's where this, sometimes if you just think x is equal to y, think of an ordered pair like 3, 3, because x is equal to y, right? So if you forget how to graph it, you can always just think of all those points and then make your line. Or you could think of a slope or something like that. Okay, so here he is all lined up, right? I have to reflect this pink line over this. So remember what we do. We count straight to the line. So count diagonal boxes. So that's one diagonal box. So I have to go one on the other side. So my new point is going to be over on this side. This is going to be my n double prime. I got to do the same thing with this m. So count diagonal boxes till you get to the line. So that is one diagonal box, two diagonal box, and a half a diagonal box. So that means I got to go 2.5. So let's go a half, and then 1 and 2. So that makes my point be right here. So this is my final resulting segment MN. He's way over here. So I scooted him to the right 1, down 3, and then reflected them over this line. And that's how he ends up being this green guy over here. So if they ask you for the ordered pairs of it, my new final n is going to be 1, negative 1. And my new final m is going to be 1, negative 4. And